can begin.
Okay. Hello everyone. Thank you for coming. Thank you for staying this late. I'm John Pretty. I'm from the UK. I'm very pleased to be here in Belarus. In particular because I'm going to talk about something I've been working on for a long time in Scala, which is based on Scala macros, which many of you may know were developed primarily by Evgeny Burmarko, who is a native of Minsk. So I'm happy to be presenting something which is built upon his work. Can I ask the audience first, how many of you are familiar with Scala? That, I think, is probably 90% of people. How many of you consider yourselves very good at Scala? Okay. So there's a big difference there. How many consider yourselves intermediate level at Scala? Okay, so what I will do today is I will go through a presentation I've given a couple of times before, but I will focus on the first half, which is the bit that I think most people will understand. There are two later parts, which on the previous times I've tried to explain this, the first time one person understood, out of an audience of about 200. On the second time he came back in a different continent, and he said he understood more of it then. That was Miles Sabin. So I won't do that. Instead, what I will do is I will talk about how the ideas that were in that second part that you're not going to see, I've put into a new library which you can use. So I'll demonstrate the usage. I won't explain how it all works. So I'm going to be talking about a feature of Scala called string contexts or interpolated strings. So is everyone familiar with these to some degree? They look. We're going to start at the value level. They look like this. So it's like a normal string, except it's prefixed with an S character. Now what that means is this now becomes a string that we can substitute a value in. And you can substitute a value in by prefixing it with $, and putting it straight in the string. And what that will do is it will take the value there called job role, which is boss, and it will produce the string as a result of this, which is literally interpolating strings like a boss, which is what we're hoping to do today. Now you can go a bit more advanced. In fact, so advanced we've come off the slide, but you're not missing much there. We can put, if we use braces, we can put any expression, any Scala expression, into that position in the string. And what's the type of this? So it's actually also a string, but in this particular example, we could have just put class of string, which is a java.lang.class. We could substitute that in, and that would also work in this particular example. I'll tell you why that's important in a moment. So this is actually a new feature of Scala, relatively new. It's about 3 or 4 years old. And it's built in the compiler on top of existing features. Now what happens is during compilation, that example I just showed you gets desugared. It gets changed from the code you write to something simpler in the compiler's view of the code. So this is what happens. What the compiler does, and this happens very early on during compilation, and it happens in a very naive or dumb, stupid way. It takes the literal parts of the string that we know at compile time. So interpolating with a space at the end, and then there's a gap, because we don't know at compile time what value is going to be placed in there. Now we had strings, but it's going to be like another gap, and then there will always be an empty string. Well, there will always be a string, which is the bit at the end. And what we do is we construct a new string context with those three known parts. Those are the bits of the interpolated string that are known at compile time. Now there are holes, and what happens to the holes is they get applied as parameters. So that's the first one, that's the first thing that's unknown, and this is the second one. They get applied as parameters to a method which is called on string context with the name that is the prefix of the string. So that S you see there is the same S there. If you used a different letter, or if you used a different identifier, the compiler would convert that to code that would look like whatever that other identifier is just there. That would happen during parsing. So this is one of the first steps the compiler goes through, is before type checking. Now when it gets to type checking, if you used some random identifier there, it probably wouldn't work because the identifier doesn't exist as a method on the string context object that we create. So the reason this works is because the string context object here either has an S method or at least looks like it has an S method. And when I say it looks like it has an S method, it's what's actually happening is there's an implicit class. Who here is familiar with implicit classes? So about half. That's good. Okay. So an implicit class allows you to add an extension method, effectively, to an existing type. And S is added as an extension method. It's not really a method that's compiled into that class, but in the compiler, it's aware that it can provide this additional S method by virtue of the implicit class being there. So that is how that is able to compile. And consequently, you can provide your own. You can add, using implicit classes, additional methods to the string context class. And using this, we can write our own interpolators. So this is what I'm planning to talk about today. So writing an interpolator, what we need is for that S method to have the right shape, to have the right number of parameters to accept that code that we saw on the previous slide. So here's a possible definition. There's S. It takes var args. So remember, these are the parameters. These are the bits that get substituted into the holes in the interpolated string. The star means we've got var args, so we can have any number of these. That's any number of substitutions in the string. And what we do is we take context is the string context. I'll show you where that comes from in a moment. We take the parts, which is a sequence of the literals, and we intersperse them. We use the intersperse method to intersperse them with the variable parts, which are these bits that have come from here, and we just join them all together. That is very similar to what the implementation of the S string interpolator looks like. Did anyone spot my mistake? The intersperse method doesn't exist, which is unfortunate because it would be very useful. It'd be very useful to just have a convenient method which says, like, alternate between these two things. We don't have that, so we can write something that does the same thing. It's maybe less intuitive, but essentially what we're doing is we're creating a list of lists. So each of these is a list. So imagine you've got a list of the literal parts, then underneath it you've got a list of the variable parts. And we put them in rows, and then we're going to use the transpose method to read them back in columns. And then we're going to flatten that into a single list. And then we're going to join them all together into a single string. Did you follow that? Good, okay. So that is my favorite way of doing this. And this has come from like various alternative approaches using folds, or you can do it with while loops, you can do it with for loops, you can zip them together. having tried all of those various methods, this is the one I like most because it's, I think, most concise. And actually even fits on a single slide, just. But there are many ways you can do this. Now, I mentioned the context, CTX. In order to get that available in our implementation of S here, this context is the string context object that we're adding the S method to. In order to get that, it is the parameter to the implicit class. So that's where it comes from. So, things to note about this. The method S that we provide here, I gave it parameters of type any, but it could have parameters of different types. It could have ints, doubles, complicated types. Anything you like can go in there. You can specify it. It just has to be the right shape. You can have any number of them. You could have an implementation of S that only takes a single parameter. Now that would work if we desugar an interpolator that only has a single substitution. If you had two substitutions, it would fail during type checking. If you had no substitutions, it would fail during type checking. So it has to match after the desugaring takes place. So we need to write an interpolator. Now, var args is a very convenient way of dealing with all of those possibilities at once. So usually you'll do that, but there's no restriction in Scala that says you have to implement it that particular way. You can overload these methods. They don't have to return a string. I mean, I know the S interpolator looks like a string, and it returns a string, but you could return an int. There's nothing to stop you doing that. The implementation can also have type parameters. As long as they can be inferred, as long as that desugaring makes sense during type checking, and from the point of view, this is a very important point about how the compiler works. From the point of view of the type checker, it's as if you wrote that code without the prefix and the string. It's as if you literally wrote a new string context with the literal parts dot s and then applied to the variable parts. And you can also take implicit parameters. There's no reason why you can't do that as long as the code fits that shape. So we have lots of flexibility here. Now, there's something interesting you can do with the dynamic trait in Scala. So has anyone here used dynamic for anything useful? It's just George, I think. Has anyone else ever seen it in usage anywhere? So dynamic trait is it's an interesting little hack in the type system that allows you to define a type, any type that inherits from dynamic trait, allows you to call a method of any name you like, anything at all, and that will compile. Now, what it will compile to is a call to a method called select dynamic or apply dynamic, which takes as a parameter a string representing the name of the method you called. So if you call .foo, it's like calling .select dynamic with foo as the first parameter, and then the other parameters get added to the end. So it's another desugaring that happens in the compiler. Now, I always wondered what would happen if you mixed dynamic with this string context stuff. Well, you can't do it because you can't implicitly convert from a dynamic. You can't convert from one type to a dynamic. You can't convert from a string context to a dynamic. It's not allowed. But I was reading late one night. I was lying in bed reading the Scala source code from the compiler. And I was looking in particular at the code that does this desugaring. And I noticed there was this comment here, which someone's written, it says, documenting that it is intentional that the ident is not rooted for purposes of virtualization. Any guesses as to what that means? So it was helpful that someone had also written a line of code underneath that was commented out, that looked very similar to a line that wasn't commented out. So they were alternatives. Now the difference was that this is exactly where the desugaring happens. One of them was saying create a new string context with these parameters. The one that was commented out was saying create a new Scala.string context with the parameters. Now the difference might be subtle. One's saying Scala.string context, one is saying just string context. What it means is that the one that's commented out says you must create a new instance of exactly this specific string context class. The one that is active in the compiler, that's not commented out, says create a new instance of whatever thing happens to be called string context that is in scope at the moment, which allows you to just create your own string context object. And remember I said before that the desugaring that happens is very dumb. It doesn't know anything about types. All it does is convert your source code into some different source code. So I thought, let's make a dynamic string context. And there's a very simple, we can just simply create a new case class string context here. It takes, remember the literal parts of the string, these are the parts. It extends dynamic, and we implement the apply dynamic method. The prefix, remember, is the name of the method call. So that's where that comes from. And then we have the variable parts as a parameter there. And all we're going to do, this is most of the slide, you're not missing much. We just return the actual prefix you use as the result of calling that method. So that is the result of a desugaring. So if you wrote something like this, we have an R string interpolator, we have a U string interpolator, we have a crazy, this is meant to say crazy talk. And what it does is it just ends up, I mean, first of all, this compiles, because we've got this dynamic string context, and it takes R, U, and crazy and joins them together. And this works. I don't know if you really want to use this. I can't think of any particular uses for it, but there may be some, and I wouldn't rule them out. But it's an example of Scala's orthogonality, allowing you to combine two features in a way that works as you would expect if you could imagine a use for it. It's not ruled out just because nobody could think of a use of it. We also get some other weird things happening. This is code that you can type into the Scala REPL, and it will. This is what will happen. There's no lines you need to type before. This is an empty REPL. You can just type equals, open quote, and then this. Can anyone explain what's happening here?
Interpolating to the wall to the equals method, which exists on the string context.
Right, yeah, and the parameter is this variable part in here. Now, because we have an empty string here and we have an empty string here, it happens that the one we call it, that sort of gets put before the equals here, is the same as this one here. And it's a case class, so case class has equality defined. It's not referential equality, it actually looks at the parameters. They're equal, and we get true. Did you follow that? Did anyone not follow? Okay. This probably seems a little bit weird and a bit useless. And it kind of is. Now, someone else suggested you can do other things like this, because there's a $hash method. This works. You get a value. It just takes the hash code. Remember, no parameters, because there's no substitutions. And we get a value. There are two opinions on whether this is a good thing or not. Again, this is orthogonality. there are no special cases which says that these methods shouldn't work. There are only, it's merely the transformation is very simple, very straightforward, and expected. So you can look at that, you remember what the transformation is, and you can work out why this happens. Paul Phillips didn't really agree. He said it was orthogonality brand lipstick when only the best will do for your pigs. So that's my discussion of sort of the first level of working with and explaining interpolated strings and string contexts. There is, I don't know if you can see, we're sort of a quarter of the way through the talk. Have a look at this. This probably looks extremely strange to you. Does anyone know this guy? This is John DeGoes. He runs the Lambda conference in America, and he was a trainer at my conference. Now this is a version of the Scala World website that went wrong. It went wrong because I messed up with CSS. I accidentally deleted one closing brace, and the whole thing. Well, no, sorry. Half of my CSS rules suddenly were invalid. They weren't applied, and the result was this ridiculous image. I mean, this is the venue of the conference, which was an image. This is John, who was doing some training at the event. This is Miles Sabin's dog, who did feature in one page. And I mean, there's some text up there. It looks. I mean, it's a bit dark. It's a bit weird. And I thought, can we do better than this? Can we do better than editing CSS and getting failures of this sort? Now, the Scala compiler has a lot of facilities for doing type checking. Now, we write Scala code and we maybe reference some CSS or some HTML in that, but the two don't really interact beyond that. So could we take advantage of the Scala compiler and the work it does to actually check that the CSS is, at the very least, well-formed, to check that all the opening braces and the closing braces match? Because that would have prevented me ever seeing that image there. And you can. One way you can do this is with interpolated strings. So what I would like to see, and what I've implemented in my Rapture library, is a lot of different interpolators that represent different DSLs of different sizes. So this is quite a small DSL. It just represents a URL. And what it will do is it will check at compile time that this is a valid HTTP URL. If I put 2 colons in by accident, it would say at compile time. And this is the really important thing. The errors happen at compile time, not at runtime. At runtime, you might as well use a plain string. It'll check that it's correct, or at least it is a well-formed URL. We can implement a CSS interpolator that checks that this is a valid CSS property, and that we have semicolons in the right place, and that the types here are appropriate for those particular values. We can do XML. We can check that this closing foo here matches the name of this one here. Otherwise, we can say it's not valid. If they fail, we get an error message at compile time. So what I wanted to do with all of this is the same thing I talk about in every single talk I ever give, which is to make your lives as programmers harder if you're trying to get code that won't work into production. I'm stopping you putting code that will fail at runtime into production by adding constraints through these examples here to your code checked by the Scala compiler. So that's the goal. And I'm going to show you a new library, which I announced a couple of days ago at the Scala Exchange, called Contextual. Now, it's got a website, and it has some documentation and examples on there. The website, if you want to have a look, it should be easy to remember. The website address is co.intextu.al. So I own the ntextu.al domain name. So by all means, have a look. Now, I'm going to show you some examples in the REPL. So I'm going to start by importing the library. And let's get some examples. Let's start with a really simple one, an email address. So oops. There is an email address. Can everyone see the text okay? So that compiled fine. It just gave us a string back. If, for example, I didn't have an @ sign, I accidentally did that, we get a compile error. Now, the thing I like about this is that it's taking advantage of another orthogonal feature of Scala, the one I mentioned at the beginning, macros. That method that you implement for the interpolator doesn't have to be implemented with an ordinary method. You can implement it with a macro, because the two things just work together without really interacting. So what contextual is it is that macro that does the checks for you. And what it does is it takes code you've written in ordinary user space code, no macros, you don't have to write any macros, and it lifts that to the macro level, and it binds that macro to the prefix here, email, but you choose what that should be. So that's a very simple example. I'll show you the source code because it's not complicated. So we've got a link to GitHub for this particular example. I've got an object containing all of the code. I don't actually use that case class, but we could do. Here I have a regular expression that is what does the main work of checking that my email address is valid. Now I'm going to create an email parser, which is my interpolator. So every implementation that you do is an interpolator. Now you have to specify a few things. The main one is the implementation method, which takes something which represents the context of the string, all the details we know at compile time about that interpolated string. Now this is the contextual type. And what we do is we take the parts. Now my version of parts doesn't involve the need to do that weird stuff with transposing and flattening. I just have a parts method that alternates between the two itself, which means you can just do for each over it, one by one, and they're either a literal or they're a whole. Now, in the case when it's a literal, we look at the value. Now, we use our regular expression, check whether it's empty, so no matches. That means we failed to match the regular expression for emails. In which case, we just call abort. Now, abort returns the compile error back to the user. So this is the second piece of code I showed you. If we hit a hole, I'm going to say that we're not going to allow substitutions. So very easy, we just say we abort as soon as we get the first attempt to substitute something into an email and give up straight away. So for a really simple example, that is all we have. Apart from one other thing, which is the implicit class, which binds that email parser we've just defined to the parameter, to the prefix email. So that's actually just a one-liner. All okay? That I think is quite easy as a way of getting compile time errors or adding more compile time constraints to your code. So here's another one. Let's import regex. Now we can write something like something like this. Let's say we want to match on foo, or foo bar, or foo bar bar, or foo bar bar bar, anything like that. We've written a regular expression, there it is, and we get a pattern back. So this is just a Java regex pattern. We can say, for example, get the matcher on, let's try one of those, foo bar bar. So that's a very concise way of writing a regular expression that actually returns a typed value. The implementation of that, I should just demonstrate that, first of all, actually, I said it matched. I haven't actually, because of the way the Java pattern matcher works, you have to tell it to match. It's a stateful implementation. But what I can show you is, for example, that if I had, well, let's say I had an extra closing bracket there, we get the error. Now the implementation, let's just go back to the website here. Now, regular expression is an example here. Let's look at the source code on GitHub. It's very much the same. We iterate over the part to that contextual object. We take the first literal we find, and we try to run pattern.compile. So anyone who's used Java has probably used pattern.compile at some point. And at compile time, we compile that pattern. If it fails with an exception, we take the exception, and we look at the message inside that. We use p.message, get message to get that. We remove some of the details we don't care about and just take the main problem, and we abort. So this is returning the error message back to the user. And I provide an index here. This is the index into the string. And what that gives us is the ability to, it's actually an off by one error there. It gives us the ability for this caret, the little arrow there, to point to the exact place where the problem is happening. And of course, with the message that is returned by that runtime code. Again, we've got the same thing here where we're joining this prefix of the regex parser to the word regex there. So I do have one quite complicated example which involves substitution, but I probably don't have time to talk through that. So I'll show you an example that does something a little bit different. Now, does anyone know of any problems with creating a new array like this? What issues might you have with that compared to what you would, maybe the same thing in Java would be, it's been years since I wrote Java. How do you do Java? You would write something like 1,2. That is the constructor for, well, that's an int array. I can't remember how you make it into bytes, but I'm so happy to have forgotten so much Java. Anyway, are there any issues with this approach compared to this approach? I'll take suggestions. Yeah.
Maybe the very construction will involve apply with several events. We build a sequence.
Correct. Yeah. So in Scala, this array takes variable argument length list, and in order for that to work, before it builds the array, it builds a sequence representing the varargs, and it passes that as an argument to the actual array construction. So we have an additional heap allocation. We're adding an extra object to the heap that we just don't need. It's not useful. It gets garbage collected quite quickly afterwards. But Java doesn't do that. Now, that's not really so much to do with I mean, if you wanted to write the same thing as Scala, you would actually say something like, you'd create a new array of bytes of size 2, and then you would say the first element is 1, and the second element is 2, and then we return the array. that does not allocate more than it needs to. It doesn't create more objects on the heap than are required. This is equivalent to what the Java bytecode gets compiled to. But we don't have a convenient syntax for that in Scala. We either write it out long, like that, or we just accept that there is a heap allocation. Now, what we can do with contextual is use the binary string interpolator, and I think that should work. Is that the right number? Yeah. Okay. So I've just created a binary value. Why is that funny? Oh, because it came out as 42. That was, I have to say, that was not at all deliberate. So, I mean, it'll do checks before that, for example, you have the right number of bits for an exact number of bytes. It will check that you don't have like a queue in there as well. We get all the error messages. But what it will do as well, I've got one more piece of source code to show you. So binary array of bytes. There are some examples. And look at the source code on GitHub. I'll talk you through it line by line, which will be quite quick. We check that all of the values are 0 or 1, or we fail. We check that the length is an exact multiple of 8, or we fail. We then convert those bits into an array of bytes. Now, this is an array of bytes which exists at compile time. It doesn't exist at runtime yet. So we then have to convert that into code which gets inserted into our source, effectively. We also can't make substitutions, so we fail there. So first of all, we get the size of that compile time byte array. And then we provide the implementation, which uses quasi-quotes. Now, this is as complicated as it gets in terms of interacting with Scala macros. I missed a bit. Yep. So for each byte, we create a statement which is assigning at index IDX the value byte. So we take our array, which is many elements, and for each element we create one statement, and then we take all of those statements which are assigning it, and we put them in here. So this will insert all of the statements one by one after we create the array of the appropriate size, and then at the end we return the array. So this is an example of using contextual for performance. It's a different purpose from the other examples. And that is, I think, quite a simple way, quite a neat way of improving the type safety of your code. Or I should probably say the compile safety, because it doesn't need to use types. There are more advanced examples which involve substitutions, and there's quite a lot of scope in there for doing extensive checks with different contexts at different positions in the code. And you can do things like embed values into, say, a JSON DSL, where it embeds different values in different ways depending on where they're positioned, or it refuses if they're positioned in a place that's not appropriate. So say you have a string, you try to substitute that into some JSON. If you substitute it into like a value position, when it does the substitution, you want to put quotes around that string, otherwise it won't be valid. You can't put the bare string in. Now, if you put that string, if you do the substitution into an existing string, you're already inside quotes. So you don't want to insert the additional quotes. Now, this is just one example. There are more complicated examples of this. But contextual gives you a very neat way, using type system, using type classes and implicits, to define how you substitute different things, different types, in different positions. I haven't got time to demonstrate that, but it's maybe the most exciting direction you can go in, because it means you can substitute all sorts of things like CSS, XML, and it means I can fix my website Well, I can stop the error happening before it happens. So I will stop there with the presentation, and if anyone has any questions, I'll be happy to answer them, or at least try.
Well, we have no time for questions. Maybe just one question. Okay.
You using Scala macros. Why you don't use Scala meta?
Because Scala meta doesn't exist sufficiently yet for it to be usable. So I would like to use Scala meta. I think it's got a long-term future, but there's a lot of people out there using Scala 2.10 and 2.11 who would like to use this straight away. So that's the reason. If anyone has questions afterwards, come and find me. I'll be around, and I'll be at the party later. So I'm happy to chat about this. Thank you.